milliohm testing using the Pico MT03A milliohm and motor tester. We're going to look at phase winding resistance. Using this tool, USB connectivity, 3.5mm jack plug into the back of the unit will measure temperature, so we'll get our temperature probe as close to the motor casing as we can. Uses the 4-wire Kelvin method. Now here's the real beauty, we're measuring each phase in one measurement, so we'll be able to do U, V and W. So you see here that we have the Kelvin clips attached to each phase. We measure from point to point, so the lead is taken out of the resistance value, will only obtain resistance of the winding, so it is highly accurate measurement. Turning to the software, we click on electric motor, confirm connectivity, accept the warning there. Here we have the UI for milliohm measurement, and click the start button. You'll notice we have a connection test first of all. We'll read the temperature and then note how current flows through the phases. So we'll have phase U to V first of all, then we'll reverse the current for the diode effect, this EMF that can be formed from dissimilar metals at connection. We'll now go to VW, again reverse the current, and so far so good. We're looking for balance, that's what's important here. Finally W to U, and we are 19.7. So the bar graph there informs us that this is a good motor. Balance-wise, it's fine. Another worthy check, especially if this is a second-hand device, is to now do an insulation test. So of course we use high voltage to measure for a short to earth, but certainly from a phase balance point of view, this is a good motor. Moving on from the phase testing of the motor using the milliohm and motor tester, we're now going to look at the resistance of a bus bar. So equally this could be a ground lead. Anywhere where we need to measure with milliohm resolution the resistance of such a lead or a bus bar. So you'll notice now we've moved from UVW. We're just going to use the U and the V phase. So still using the Kelvin method, but we're connected to a bus bar. We're going to measure the resistance between these 2 points. Now on the bus bar we have 2 eyelets, and through those eyelets we have 2 bolts, and our Kelvin clips are attached to each bolt. So we'll get the resistance through the bus bar and ultimately the contact connection through the bolts as well. So it'll be an entire measurement. We'll move across now to the software. It's milliohm meter test. So you'll hear the chime there, we're actually connecting, confirmation of connection. And there we have the screen, and already you can see we're logging resistance. So again, we're measuring between U and V, U, V. Notice the temperature. I've moved the temperature probe from the motor now, and I've attached it to the bus bar because we're able to compensate for temperature. Now, the blue line, of course, resistance, red line is temperature in the graph. I want to have a look at the effects of the bolt tightness and how that affects resistance. So watch closely the resistance. At the moment we are 0.7 milliohm. So just think about that, 0.7 of a milliohm. I'm just going to crack this bolt. So I haven't actually undone that, so we're now at 2.1 milliohm. So I cannot turn that bolt by hand. So I'll now slacken that off a little bit more. You see how that is changing? And it's still not. You can see actually, the clip is just resetting. If I move that, we can see the resistance changing. Let me just come off a little bit more. Yeah, and we're now up to, I think there was a point there where we went to 10 milliohms. So if you think about that, think about 100 amps passing through there. Amps times resistance equals voltage. That'll give us the voltage drop. So for 10 milliohms with 100 amps, we're looking at 1 volt drop. So it's just to kind of hopefully bring home the importance of measuring milliohm with such high resolution and high accuracy, which will be ensured using the milliohm and meter tester. So I hope that really helps in terms of the importance of milliohm testing with high resolution.